Good morning, class 11. Today in this video you are going to study about coefficient of variation under the chapter measures of dispersion. Well children, coefficient of variation is also known by the name of Karl-Pearson coefficient of variation, and the reason because this method was first used by the famous statistician Karl Pearson. According to him, coefficient of variation is the percentage variation in the mean, where the standard deviation is being considered as the total variation in the mean. So students, in order to calculate coefficient of variation, standard deviation of the series is divided by mean of the series and multiplied by 100. So it could be estimated by a formula, that is standard deviation upon mean into 100. Now coefficient of variation could be calculated by three different series, that is individual series, discrete series and frequency distribution series. Now I am going to explain you each series one by one. So let's start with the first one, that is individual series. Now if you see, there is a data which has been given from which we have to calculate coefficient of variation, and the data goes like this. You have a serial number from 1 to 10 and then your marks, that is 53, 58, 25, 30, 54, 42, 32, 48, 46 and 52. Now if you see, there is a table and this table has a 4 columns. In the first column I have taken serial number as it is given 1 to 10. In the next column I have noted down the marks, which is X, 53, 58, 25, 30, 54, 42, 32, 48, 46 and 52. Now what I have done, I have added all the X together and I got sigma X to be as 440 and your N is 10. Now children, we have to find out the deviation, and to find out the deviation we need to find out the mean, because you need to minus the value, that is the mean, from the value of X. So you know how to calculate mean by direct method, that is sigma X upon N, which equals to sigma X is 440, N is 10, so your mean is 44. Now with this mean to be as 44, we are going to find out deviation. So we'll minus 53, which is the value of X, from the mean, which is 44. So 53 minus 44 you get 9. Then 58 minus 44 you get 14. Then 25 minus 44 you get minus 19. Then 30 minus 44 you get minus 14. 54 minus 44 you get 10. 42 minus 44 you get minus 2. 32 minus 44 is minus 12. 48 minus 44 you get 4. 46 minus 44 you get 2. And 52 minus 44 you get 8. Now in the next column we are going to square up the value of X, that is the deviation which we have taken out. So when we square up 9 we get 81. When you square up 14 you get 196. When you square up 19 you get 361. 14 you get 196. When 10 you get 100. When you square up the value of 2 you get 4. When you square up the value of 12 you get 144. With 4 you get 16. You square up 2 you get 4, and with the square of the 8 you get 64. Now we'll add all the values of X square together. So we get sigma X square to be as 1166. Now the first thing we will do, we'll find out the standard deviation, and here we are going to use the formula of direct method, that is already people have done. You have calculated standard deviation by direct method, the formula is square root sigma x square upon n, or square root sigma in bracket x minus mean bracket close square upon n. So your sigma x square is 1166, n is 10. When you divide it, you get square root of 116.6. And when you find out the square root of 116.6, you get 10.8. Now this is your standard deviation. From this standard deviation, we are going to calculate coefficient of variation. So coefficient of variation equals to standard deviation upon mean into 100. So your standard deviation is 10.8, your mean is 44 into 100, and you get your coefficient of variation as 24.55. So children, this is how you can calculate coefficient of variation by individual series. Now if you have to calculate coefficient of variation by discrete series, so let's see how we can calculate. So again, there's a data which has been given, that is of items and frequency. And items which are given are 10, 12, 14, 16, 18, 20 and 22, and frequency is 4, 6, 10, 15, 9, 4 and 2. Now if you see, again there's a table which has been drawn. It has 5 columns. In the first column, I have noted down the items, which is actually x. In the second column, I have noted the frequency. So, and the third column will take out the deviation, then we'll multiply the deviation from frequency, and then we are going to square up the value of x and multiply it with the frequency. So, items are 10, 12, 14, 16, 18, 20, 22, and your frequency is, as it has been given, 4, 6, 10, 15, 9, 4 and 2. Now to find out the deviation, we have to assume one number from the value of x, that is items, and again it is up to you which number you want to assume. I have assumed 16. So now let's minus the x from the assumed number. So 10 minus 16 comes to minus 6, 12 minus 16 is minus 4, 14 minus 16 is minus 2, 16 minus 16 is 0, 18 minus 16 comes to 2, 20 minus 16 is 4, and 22 minus 16 is 6. Now we'll find out FDX. We are going to multiply this deviation from the frequency. So our first frequency is 4, deviation is minus 6. So multiply 4 into minus 6, you get minus 24. Then 6 into minus 4, you get minus 24. 10 into minus 2, you get minus 20. 50 into 0 will be 0. 9 into 2, you get plus 18. Then 4 into 4, you get 16. Then 2 into 6 is plus 12. Now children, very important part, f dx square. Now over here, what you have to do, how you are supposed to find out f dx square, you are going to square up the value of x, means minus 6, minus 4, minus 2, this value has to be squared up first and then it has to be multiplied with the frequency. So minus 6, when you square up, you get 36. You multiply 36 from 4, you get 144. Then 4, if you square up, again it is 16. When you multiply 16 with frequency 6, you get 96. Then when you square up 2, you get 4. When you multiply 4 with 10, you get 40. 0 will be 0 only. When you square up 2, you get 4. 4 into 9, you get 36. When you square up 4, you get 16. When you multiply 16 with 4, you get 64. When you square up 6, it is 36. When you multiply 36 with 2, you get 72. So children, now what we'll be doing it, Under FDX, we are going to add up all the negative sign together and all the positive value together, and then we'll minus, and we get sigma FDX to be as minus 22, and we get sigma FDX square to be as 452. Now, you know very well that to find out coefficient of variation, you need to know the value of mean, and to find out the mean, we are going to put it into the formula, that is mean equals to A plus sigma FDX upon N, where your mean equals to assumed number is 16 plus sigma FDX is minus 22, N is 15, and you get your mean to be as 15.56. So let's put the value in the formula of standard deviation by shortcut method, which is square root sigma FDX square upon N minus in bracket sigma FDX upon N bracket close square, and when you put the value of sigma FDX square, you get that is 452, your N is 15 minus in bracket sigma FDX is minus 22 upon 50 square up, and you get your square root to be as 9.04 minus in bracket minus 0.44 square, which comes to square root 9.04 minus 0.1936, and you get a square root of 8.8464, and when you find the square root of 8.8464, you get your standard deviation to be as 2.97. Now we are going to put it in the formula of coefficient of variation, which is CV equals to standard deviation upon mean into 100, where your standard deviation is 2.97, mean already we have found, that is 15.56 into 100, and we get 19.09, which is your coefficient of variation. So children, this is how you can find out coefficient of variation by discrete series.